Can you guys hear me in the back when I talk like this? Just don't mind the German accent, it's just about the volume. Welcome to the Science Slam. I have the honor to being the first presenter, and my topic is Biomimetic Proton and Halonium-induced Cyclization reactions and total synthesis of neoproteomycin natural products. Thank you. So this is usually a slide I show when I give presentations, when I go to conferences and stuff, and you present your work. And it's basically, those are the neoproteomycin's product. They were isolated from some bacterial strains. There's a very fancy mechanism here, so for all the organic chemists out there, you might really enjoy this because this is actually quite awesome what I did. But since this is a more leger and a more easygoing event, I thought I'd give it another title and just call it The Joy of Organic Chemistry. So moving forward, whenever I tell people, well, I'm a chemist, I'm an organic chemist, or I work in research, they always say the same thing, well, I had it in school and it fucking sucked, it was stupid, or my teacher was bad and the science was bad, and I mostly agree with that. But there's also some other negative recollections for the chemistry in general. So for example, when you talk about food chemistry, when you have chemicals in your food, that's considered bad. Of course, there's also a chemical warfare agent that also has quite a bad reputation. Of course, there's the drugs. And just before anybody asks, yes, I can make meth, actually pretty good meth. I just choose not to because I don't want to. Also, it's, I think, illegal, I've heard. But also there's a positive about chemistry. And by the way, organic chemistry is usually the chemistry with these little benzene rings, with these hexagons some people might have seen around. But it's much more than that. So it's, for example, it's found in plastics and colors. It's found in food, so all the sugars, proteins, stuff like that, that's all considered organic chemistry. Drugs, helps a lot of people. So this is also small molecules usually, and you get better with those. And for example, also organic LEDs. That's also everything in the realm of organic chemistry. So that's why I really enjoy the field in general. Recently, some people may recognize this guy, Morten Mellel. He just won some prize a few weeks ago. And he had a very, very inspiring quote, and he said, chemistry is everything, like this table, the air you breathe, your body, your beer, so everything except light and space. And he was actually very right, because also life basically is chemistry. So photosynthesis, Krebs cycles, stuff like that, everywhere chemistry can be found. And this is where my topic basically ties in. So a few years ago, some Japanese scientists, very smart and fun people, they went on a dive, and what they did, they collected 50 kilograms of a marine sponge. So they went down, collected this in big bags, and then they were kind of curious, what is that sponge made of? What does it do? And what they did, they basically put it in a blender, and afterwards they took the smoothie and took a deep dive and looked what is found there. So of course all the cellulose was removed, and they found this fancy molecule. So from 50 kilograms, he had 0.5 milligrams of this molecule was found in this sponge. And the thing with nature is it doesn't never, or very, very seldomly, do something without any proper cause. The scientists were curious and say, oh, why does this sponge make this molecule? And it was found that it's actually quite good in killing a virus, so a rhinovirus. And that really sparked the interest, because you can imagine if you have the virus as a human, it would be nice to have a medication. So the idea was basically to have this molecule and make it into a medicine and just study it a little bit more, see what it can do. But the problem is, you can see here, you cannot really collect 50 or 5 tons of the sponge to make this drug. So that's why I come in. I wanted to make more of this molecule, if that makes sense here. So how does one actually make a molecule? That's the big question here. How do you build a molecule? And some of my colleagues, they are reluctant to agree, but I would really say that chemistry is a little bit like baking. And just follow me through here. So what you do when you bake a cake. So first thing you do, you go shopping, right? So you go to the grocery store, you get the ingredients, then you weigh them out, so you have your flours and your peas and stuff. Then you determine the order in which you mix it. So for example, if you mix these nuts with the egg yolk right away, and then add the flour later, you might gonna have a bad cake afterwards. So you really have to do everything in the proper way. You mix it up, then you put it in the oven, usually at 150 to 250 degrees in a normal cake bake. Then you have the finished product, you remove it from the form, Then you do this a couple of times, you make different layers, you glue them together, and then in the end you have your final cake if you did everything correctly. So in chemistry it could be considered quite similar. So the first thing you do is you go shopping. So we actually have a website, Sigma Aldrich, and it's like Amazon for chemicals. You can just, with your organization or something, you can just go there, buy the chemicals you need. You weigh them out, usually in smaller quantities, about 200 to 500 milligrams. Then you also go and see what order you put the chemicals in, and then you don't have one of those big bowls here, but you usually have a reaction flask. So you say, okay, first go this the chemical, then a little bit of this, a little bit of that. But the problem here, and that's the difference from making a cake, if you do something wrong, if you add the chemical too fast or the wrong one, it can just go all haywire, and your flask can explode, it can boil over. If that doesn't happen, then you go to the temperature selection, and we have a little broader spectrum, I would say, so from -80, so the coldest temperature recorded on Earth, up to 450 degrees, so roughly the temperature of the surface of the Venus, so a little bit broader range. And again, if you choose the wrong temperature, then it can go bad and explode in your face. Well, you don't want that. In the end, you don't have a cake, you sometimes have a filter cake, so you collect your chemicals, and then you do this a couple of times with different reactions, and in the end you don't have a cake obviously, but you have your chemical here. That's what you want to make. So those are the basic steps at how to do a reaction, and then you repeat this process, add this chemical to other things, and so on. But of course the problem is, and that's why it's a little bit different from baking, you don't have really a cookbook. So if you want to make a new molecule, a molecule that has never been made before, you just can't go to the library and find a recipe book. That's just not the way it works. So you have to invent the recipe for each single step here. And of course, if you want to make a good cake, you have to make a lot of cakes. And that's what I did. So there was a lot of failure, a lot of fuck-ups, yes, a lot of crying, a lot of tears, a lot of long nights in the lab. Obviously, that's usually always what they say about the PhD students, right? They just, work until after 12. But the goal was to make this one single perfect cake. And yeah, well, that's basically the summary. So down here on the right-hand side is my molecule. And just to give you like a rough idea of the synthesis here, so the first molecule on the top left, we used about 20 grams. And the first step to the second molecule, that process took about half a year to do. So it's 4 steps. But you have to do a lot of optimizations. You have to screen the temperatures, the solvent, what chemical goes where. And it was really tricky. So it was a half a year for each arrow, roughly, to get to the next stage. And then you go to the next stage, another 3-4 months. And that's really where it comes down. And then eventually, for the people in the back who can't see, so we have 20 grams of the first molecule, 2.5 milligrams of the last molecule, of the target molecule. So I basically made the cake, which is nice. And you might say, well, 2.5 milligrams, that's not a lot, but remember that it is 5 times more than from 50 kilograms of sponge. So we don't have to kill the sponge pops anymore. We can just make it in the lab. We can do different molecules that are a little bit similar, and also study what they can do, what other bacteria, viruses they can kill, and maybe at some point, that would be the idea, make a drug out of it and sell it, and basically help the human population here. And even though the last slide might be a little bit confusing, my take-home message as a chemist with enthusiasm is that chemistry is not always bad. I mean, sometimes yes, but not always. It is very useful, and it's also everywhere. So with that, basically, please do join me in doing some chemistry. So even if you drink a beer, metabolize it into acetate, you're doing chemistry. So have fun doing chemistry today, and cheers.